burning with the fire of the sun. The electric arc furnace renders molten steel. White, hot metal is extruded into enormous slabs. The rolling mill presses raw steel into high-strength armor plate. These are the bones of the most powerful warship known to man, a Nimitz-class aircraft carrier. It takes 7 years and over 30 million man-hours to build a Nimitz-class carrier. With a crew of nearly 6,000, the ship is a mobile airbase for 80 state-of-the-art warplanes. Fully loaded, she weighs 97,000 tons, nearly 200 million pounds. Her 4.5-acre flight deck is as long as the Empire State Building is tall and could encompass 3 football fields. Construction of a Nimitz-class carrier represents the most complex shipbuilding challenge ever undertaken. Virginia's Newport News Shipbuilding Company has been at the vanguard of carrier design and construction for over 3/4 of a century. It is the only facility capable of building these mammoth warships. As of early 1998, 2 of these supercarriers were under construction. The Harry S. Truman was nearing completion, while the Ronald Reagan was at the start of its building cycle. The carrier begins its life as bits of data in a virtual world. Major portions of the carrier's structure and some of her more complex systems are created in the computer as solid, full-size, 3-dimensional models. The computer model accounts for every one of the millions of pieces of steel used in these assemblies.
With the 3D model, we can see the entire arrangement within a particular space. What we try to do is clean the design up, remove any fouls between structure and maybe pipe, make sure that the sailors on board have accessibility. They can read dials, they can get to places they need to without any conflict. We clean the design up long before we get to any manufacturing.
With the final design approved, it's time to build the carrier for real. Steel is cut according to plan, and the pieces are welded together to form basic structural units. These basic units are combined to form large modules called superlifts. The completed superlifts are lowered into the dry dock and joined together to form the ship. Of course, this is easier said than done.
We get little pieces called base A units from down the road, and it's just like putting a puzzle together. You get little pieces, you weld them together, you make bigger pieces, you weld those together and make bigger pieces. The bigger pieces are what I work on, which are the superlift units, and I'm in charge of the structural completion on the superlift units. This yellow mark right here is just basically if the weld looks like it penetrates too far into the steel, you have to weld an undercut. So they'll just go back and they'll put another bead of weld there and grind it flush.
It takes a crew of 25, working in the various crafts or trades, more than 3 months to complete even one of these gigantic puzzle pieces.
So once we make a superlift, it's 900 tons, we'll put it on a crane. Just like a part of the pyramid, you lift the enlarged portion, which is the super lift, down into the dry dock, where we combine all the other super lifts as more puzzle pieces to make what eventually will become the ship.
Spanning Dry Dock 12, the Krupp gantry is the largest crane in the Western Hemisphere, with a lifting capacity of 900 metric tons. The crane operator works the controls from a small bubble, 25 stories above the dry dock floor.
It's pretty exciting to come in knowing that you're operating one of the biggest cranes in the world and some of the things we do. I guess it's not for everybody being up here by yourself all day, but you just have to get in the mindset. And next, I've been doing it about 22 years. I started off operating small stuff and worked my way on up. I guess I can't get much higher than this, really.
The crane's task on this day is the reorientation of this 730-ton hull section. It is often easier to build a superlift upside down or on its side, as is the case here. This unit is finished, ready to be lowered into the dry dock. But first, it must be turned upright.
All right, coming up.
Shipyard veteran Bill Ballou supervises the heavy lift.
I've been employed by Newport News Shipbuilding for 38 years. I've been in the North Yard working these cranes for approximately 22 years. Every carrier that's been built at 12 Dock, I've been involved in it from the beginning to when she set sail into the James River, and that's been, this will be our 4th aircraft carrier.
While smaller pieces can be turned by the crane alone, large superlifts must be rolled over in a giant sand pit. The immense size and weight of the superlift makes this a daunting task.
It looks good to me, Billy. Put her on the ground.
All right, working it down easy.
All right, Robert, put the axe on her. We'll hook her up on the other side.
The 9 crane cables are reattached to the actual topside of the unit.
Hey, get your twist out here, over here, baby. Twist out, Chili. Do it. You gotta do it. Let me get on that. Get the twist out here. Come on, baby. Twist out that right push. There you go. Hey, chill up, you gotta do it. Jump in with it now. Be quiet, fighter. Get on. Get on all the ears so you can get on.
The crane takes up the slack. Like a waking giant, the superlift stirs.
She's digging in the pit right good, Dave.
The sand gives way under the mass of the superlift, preventing the bottom edge from being crushed by its own weight. Wooden blocks are positioned to catch the piece as it reaches its center of gravity. Without them, the superlift could tip too far, subjecting the crane to a potentially catastrophic shock load. It has taken almost 2 hours to reorient this superlift. It will take another 3 hours to move it to the dry dock and correctly position it against the ship's framework. In the machine shop, crews labor to complete the carrier's propeller shafts, which must be installed before the ship's engine room is covered over. This shaft section is 66 feet long, 2 feet in diameter, and weighs 52 tons. It will take 7 such pieces to make up just one of the carrier's 4 propeller shafts.